Space weather, the silent threat to our technological world. Did you know that a storm from the sun can knock out power grids on Earth? This is the power of space weather. It's a fascinating and often overlooked aspect of our universe. Space weather refers to the changing conditions in space driven by the sun's activity. These changes can have a profound impact on our technology, especially our satellites and communication systems. Imagine a world without GPS, television, or even some radio communication. That's what's at stake when space weather turns extreme. Understanding and predicting space weather is crucial for safeguarding our technological infrastructure. It's not science fiction, it's about protecting our way of life. Solar flares, when the sun throws a tantrum. Solar flares are sudden, intense bursts of energy from the sun's surface. Imagine a billion atomic bombs exploding at the same time. That's the kind of energy we're talking about. These flares release a torrent of radiation, including X-rays and gamma rays, which travel at the speed of light. When a solar flare hits Earth, it interacts with our ionosphere. The ionosphere is a layer of our atmosphere that's filled with charged particles. This interaction can disrupt radio communications, especially high-frequency communications used for aviation and navigation. Solar flares can also interfere with GPS signals. GPS relies on precise timing signals from satellites. The interference caused by solar flares can introduce errors in these signals, making GPS navigation unreliable. These disruptions can be more than just an inconvenience. They can have serious consequences for industries that rely on precise timing and navigation. Coronal mass ejections, billions of tons of plasma hurtling through space. Coronal mass ejections, or CMEs, are even more powerful than solar flares. These are massive eruptions of plasma and magnetic field from the sun's corona, the outermost part of its atmosphere. Imagine a billion tons of superheated gas hurled into space at millions of miles per hour. That's a CME. When a CME reaches Earth, it can trigger a geomagnetic storm. This happens when the CME's magnetic field interacts with Earth's magnetic field. The result is a disturbance in our planet's magnetic field, which can have widespread effects on our technology. CMEs are a serious threat to our power grids. The fluctuations in Earth's magnetic field caused by CMEs can induce currents in power lines. These currents can overload transformers and cause widespread blackouts. Imagine a major city plunged into darkness due to a storm from the sun. Geomagnetic storms, Earth's magnetic shield under attack. Our planet's magnetic field, also known as the magnetosphere, acts as a shield, protecting us from the constant bombardment of charged particles from the sun. But when a CME hits, it's like hitting our planet's shield with a sledgehammer. The magnetosphere gets compressed and energy is transferred into Earth's upper atmosphere. This influx of energy can heat up the atmosphere, causing it to expand and increase drag on satellites in low Earth orbit. Increased drag can cause satellites to slow down and even fall out of orbit, potentially leading to collisions and loss of valuable assets. The beautiful auroras, both the northern and southern lights, are actually visible evidence of geomagnetic storms. These shimmering curtains of light are caused by charged particles from the sun interacting with atoms in our atmosphere. It's a reminder that even the most beautiful phenomena can have powerful and sometimes disruptive effects. The relationship between the sun and Earth is a delicate dance. The sun gives us life, but it can also unleash powerful forces that can disrupt our technological civilization. Space weather is a constant reminder that we are part of a larger cosmic ecosystem. Understanding space weather is not just about protecting our technology, it's about understanding our place in the universe. The sun is a star, and like all stars, it is dynamic and ever-changing. We live in its atmosphere, and we need to understand how it affects us. Think of it like this. If you lived at the bottom of the ocean, wouldn't you want to understand currents, tides, and storms? Of course you would. Space weather is like the oceanography of space. We need to learn its patterns, its extremes, and its potential impacts to thrive in this cosmic sea. Fortunately, we are not helpless against the whims of the sun. Scientists are constantly working to improve our ability to forecast space weather. Just like we predict the weather on Earth, we can now predict solar flares, CMEs, and geomagnetic storms, giving us time to prepare. Space weather forecasting relies on a network of ground-based observatories and spacecraft that monitor the sun 24/7. These observatories track sunspots, solar flares, and CMEs, providing crucial data for predicting space weather events. Early warning systems can give us time to take preventative measures. Imagine a hurricane is approaching the coast. Meteorologists track the storm, predict its path and intensity, and issue warnings. This gives people time to prepare and evacuate if necessary. Space weather forecasting works in a similar way, providing crucial time for mitigation. One of the key tools in our space weather arsenal is the Solar Dynamics Observatory, SDO. This spacecraft, launched in 2010, provides high-definition images of the sun in multiple wavelengths, allowing scientists to study solar activity in unprecedented detail. It's like having a weather satellite pointed directly at the sun. Another important tool is the Advanced Composition Explorer, ACE. ACE sits between the sun and Earth, measuring the solar wind and providing about an hour's warning of potential geomagnetic storms. It's like a buoy in space, sending us real-time data about incoming solar weather. These are just two examples of the many sophisticated instruments used to monitor the sun and predict space weather. As technology advances, so too will our ability to forecast space weather events with greater accuracy and lead time. Protecting our satellites, shielding our eyes in the sky. Knowing about an impending solar storm is just the first step. We also need to protect our technology from its effects. Satellites are particularly vulnerable to space weather, but engineers have developed several strategies to mitigate the risks. One approach is to design satellites with radiation hardening. This involves using materials and components that can withstand the harsh radiation environment of space. It's like giving our satellites a suit of armor to protect them from the sun's wrath. Another strategy is to adjust the orientation of satellites during a solar storm. By turning the satellite so that its most sensitive components are facing away from the sun, we can minimize the damage. It's like turning your face away from a strong gust of wind. The future of space. Weather forecasting towards greater accuracy. Space weather forecasting is a relatively young field of study, but it's rapidly evolving as we learn more about the sun and its effects on Earth. Scientists are developing new models and algorithms to improve the accuracy of our forecasts. One promising area of research is artificial intelligence. By feeding vast amounts of data from solar observatories into AI algorithms, researchers hope to identify patterns and make more accurate predictions. It's like using AI to analyze weather patterns on Earth, but on a solar scale. Imagine a future where we have personalized space weather forecasts, just like we have weather apps on our phones today. This information would allow us to make informed decisions about space missions, satellite operations, and even our daily lives. Living with a star space weather and the future of humanity. As we venture further into space, whether it's to the moon, Mars, or beyond, understanding and mitigating space weather will become even more critical. Astronauts on deep space missions will be particularly vulnerable to solar radiation, which can increase the risk of cancer and other health problems. Space weather can also impact our plans for establishing a permanent human presence on the moon or Mars. These celestial bodies lack the protective magnetic field that shields Earth from the sun's fury. We'll need to develop innovative ways to protect astronauts and habitats from the harsh radiation environment of deep space. Space weather is not just a scientific curiosity, it's a fundamental aspect of our existence in this universe. As we become a more spacefaring civilization, our ability to live and thrive in space will depend on our understanding and respect for the power of our sun. Space weather awareness. Knowledge is our best defense. Space weather is a fascinating and complex phenomenon that has the potential to impact our lives in significant ways. While we can't control the sun, we can learn to understand and predict its behavior. Just like we check the weather forecast before leaving home, we need to be aware of space weather forecasts and take appropriate precautions. This includes protecting our satellites, power grids, and other critical infrastructure. By increasing our knowledge and awareness of space weather, we can mitigate risks and ensure the safety and reliability of our technological systems. The future of space exploration and our technological civilization depends on it. Remember, knowledge is our best defense against the fury of the sun. The power of collective awareness. If you learned something new from the video, then please give a like to the video and share your opinions in the comments. Don't forget to subscribe for more such content and also share it with your friends and families. By spreading awareness and knowledge about space weather, we can collectively prepare for and mitigate its impacts. Every like, share, and comment helps to build a community that is informed and ready to face the challenges posed by our dynamic sun. Together, we can harness the power of collective awareness to protect our technological world and ensure a bright future for all of humanity. Thank you for watching, and stay curious.